me record. So we saw that in the case of 3 sets, well, it gets a little bit more involved with pictures, as we have not just intersections of 2 sets, but of 3 sets at the same time, and then just 2 sets, but not third. And it's possible to visualize everything here on the figure 2.21, the one that I just opened in here. So that's our Venn diagram. So we utilize these diagrams to do various little exercises, and we also had a quiz on that section. So let me find the problem that we did for quiz last time. I think it was number 34, right? So exercise. Yes. Thank you. 34, we were supposed to see the elements of the set B, and I guess pretty much everyone did it absolutely correctly. So you could just list everything covered by this set B. So it looks like if I start with 4, 5, 6, although it doesn't really matter how you are going to list them in what order, because the set is still going to be unchanged. And it looks like in my case here, I have a bunch of numbers. It looks like there are 6 of them that all appear in the set B. So I guess if you just carefully check the picture, then you see what is happening. So let me do one more here. If you have any questions, if you would like me to do some exercise, just let me know, because I'm here to help you to do some homework problems. So if you found anything in this section or in the other sections, let me know, we'll do it together. So how about if I try one problem with 3 sets at a time, like for example, exercise number 42 that talks about the union of sets A, B, and C. So they're talking here about everything that looks like that, right? Number 42, I got the union. So I need to take everything that is covered by these 3 sets by either one of them. And you can see that pretty much all the elements here are present, except for only one of them, except for number 13. So I'm not going to list all of them. I'll just say ... all the way through 12 is here, and then 13 is out. So if someone considered next problem number 44, then looks like the complement of this set that I just highlighted in red will have element 13 in it, because that'd be everything on the outside, right? If you want to do number 44, well, I highlighted it with yellow, so you can see that this yellow stuff, whatever's on the outside, will have that element 13 as the only one left over in here. So this is the way to go with this exercises. If picture is available, then it's great, and then you can just utilize it right away, as everything is in front of you. So it is definitely very convenient. Well, so if you have any questions and nothing else, I can see what else this section has. So it looks like the next page takes a little time to get to the next page. Huh? I think it's still working Okay, there it is. So next page has practice plus exercises. So I would say you don't have to worry about the next page. It's all pretty much over. So I would just say, look at the page before page 95. I think last time we already saw that little section here. So maybe I can do one exercise here and then we can move on. So I don't want to be stuck with this forever. I know there are lots of problems here, but I'm sure if you know how to do a couple of them, then you're already pretty clear on what is really going on. So let me try to construct Venn diagram here, like in exercise number 45, where they have 3 sets and they want me to produce diagram that deals with those 3 sets. So in exercise 45, I'm gonna make a picture that has 3 sets in it. I should make it bigger so I can have enough room to put all the elements in it, somehow like that. So I'm trying to resemble pictures that we have in this section. So now I need to carefully construct Venn diagram, but I need to be very careful. I need to see if there is anything in common for all of these sets. So for example, if I look at 3 sets A, B, and C, then I can notice that there is one element, and it's actually element 4, that belongs in all 3 of them. So let's say this is my set A, this is B, and this is C. So notice that there is a one common element for all 3 sets here. One element that belongs to all of them at the same time. Okay, so we can now start with the sets A and B. So if I just select, let's say, this 2, set A and a set B, and disregard set C at all, then I can see that besides number 4 in a set A and B, I also have 2 more elements, 5 and 6, right? So elements 5 and 6, they belong to and A and B at the same time. So what I need is to try to put it here, 5, and then also 6 right there on the common part between A and B on their intersection. Well, 4 is already present in here, so 4 I don't really want to touch. So anyways, looks like I'm going kind of inside out. So it started from very center where we had intersection of all 3 sets. And now I'm moving towards the intersection of 2 sets at a time. So I just considered sets A and B. So now I can try another pairs, such as, for example, intersection of set A with a set C, which is here. So now I'm going to disregard set B completely and check out what's common in those 2 sets, A and a C. And if I look closer, those 2 sets looks like there is nothing going to be common. So there'll be no elements, here, right? No elements here where the sets A and C are, because again, they don't have anything in common. Do you see that? See, it's pretty detailed, so one needs to be careful looking at this picture. So set A and set C, right? And yes, they have 4 common in between of them, but 4 is already utilized. So nothing else, 3 and 7 here, and there's no 3, 7 in a set A. Well, that's fine. That just makes life easier. So now I'm gonna consider the last pair of sets, and those be sets B and C, right? So now I'm gonna think of set B as well as set C right there, and see what happens with those two. So set B and C looks like they do have a common element, and that's element 7, right? And I'm gonna put it right there, element 7. All right, so that looks good. So maybe I'll take away this question mark. There's nothing in there, and that's okay. So we considered all pairs of sets. So now I need to put the remaining elements, such as what's only in A, what's only in B, what's only in C. And this means I'm going to take 8, because that's only element of set A. You don't see it anywhere else. Then I'm looking at the set B, and I see only 2 numbers that left, 1 and 2. So I put them here, only in the set B, right? And finally, in the set C, there is also a special element. It's a number 3 that is only in the set C. So I have put everything inside of those sets, but there is one more thing that I need to keep track of. Remember, there is so-called universal set. Like in the previous example that we did, there was element 13 that did not belong to any sets that we have. So the question will be, do we have anything like that in here as well? Well, let's check it out. I need to now look at the universal set and see what else is here and that wasn't listed as of yet. And I think I see number 9, the very last one, right? Because it looks like we already have here 1, 2, and then 3 is in the C, and then 4 is in the middle, 5, 6, 7, and 8 everywhere. So on the very outside, I have a remaining piece, which is only one element, number 9. So something like that, and we have done with this exercise. It turns out that at this stage, I think we should end with this chapter, because next section is even more involved with the 3 sets and their intersections, and that's just, I guess, going to be a little bit more and more complicated. So talking about survey problems. So I usually skip that section 2.5, so we don't really need to worry about this. And you can see they again go over this Venn diagrams, and they're just more and more involved with this 3 sets. I think we had enough of that stuff, so we can just move to the next chapter, turns out, because this concludes chapter 2, and now I'm starting to look at chapter 3, which is in a way utilizes those ideas from chapter 2, but it is a quite different story because it's called logic, and that's what we're going to deal with in chapter 3. So first section of chapter 3 is talking about so-called statements. And say, oh, statements, it could be just make any sentence. Well, not really. So they say that statement is a special sentence that could be either correct or incorrect, but it cannot be correct and incorrect simultaneously. So there are some things that contradict itself, or something that doesn't really make much sense is not what we want to consider in logic. So somebody can make a correct statement or incorrect. So that makes it be in the form yes or no, or they say true or false. So those things are good to realize. For example, here's the statement: the London is the capital of England. So it sounds that this is correct, and that the London is capital of England, so it's a statement. What if somebody says New York is capital of England? Well, that's also a statement, but that's not correct because New York is not the capital of England. So could be correct, could be incorrect, but it's still a statement. Well, so what is not a statement? Well, if you look at example 2 here, that has a question mark, it's not going to be a statement because this is a question. So again, the statement may be only correct or incorrect, but looks like we have, well, other things that may be around. Well, I don't want to get too much into all that because we are going to deal with statements in this class. And of course, there are various other examples that one can come up with, but there are some statements that we're going to see from now on. So another popular part in logic is so-called negation. So somebody will produce negation of statement if you just enter word not. So for example, if somebody says in a part B here, July is not a month, well, looks like there is some kind of statement made here. Whether it is correct statement or not is another question. One may not agree and say, no, this is a false statement because July is a month, right? So one can say this is a false statement actually, but it is still a statement. Well, what they want to do is produce a negation here. Well, I say, Alex, but it's already has a negation. Well, to negate it means I need to get rid of that not, and this way you're going to produce a correct statement that will say that July is a month, which is now going to be true. So notice that statements have very interesting structure. So they are either true or false. And if you negate them, again, you're going to get either true or false as a result. So it looks like that negating something, you need to either put not in it or get rid of not that I just did here. So if I try to, yes?
I'm so sorry to interrupt. I have a small family emergency to get to. I'm so sorry. I'm going to have to leave.
Oh, you don't have to tell me that. You just put your name in the Zoom chat so I know that you were here.
Okay. Sorry, Professor, about leaving early.
Oh, that's fine. I'll send you a lecture so you'll be able to watch it if you want.
Thank you, sir.
Okay. So anyways, back to this story of exercise A that says, how about if we negate the statement that Paris is the capital of Spain? Well, if you know, looks like this is not a correct statement because Paris is in France, right? So it's not in Spain. But anyways, if somebody wants to negate the statement, you either put not or you get rid of not, just like we did before in the previous example. So looks like here I should put is not. Try to fill it here. Paris is not a capital of Spain, and that's going to be negation of the previous one. So the point of story is to negate something, we either put a negation, we say not, or we get rid of negation, just like I did in the next example. Well, so it's just the introduction, so we'll be getting used to this a little by little, and that's the plan for today. So also there is a special symbol that this text is using for negation. It's like a wiggly line next to the, actually in front of the statement. So this means not Q. So instead of word not, they will put this little wiggle. I'm going to say, Alex, What if I don't put that wiggle? What if I just use word not? Well, that's fine with me. I will understand. But I think it's good that you realize what that means, because when you do homework, you will see this in lots of exercises. And
Professor,
yes,
what is the difference between this symbol that you just show us with Q and the other one with P?
so what's the difference that with this
Yeah,
symbol?
like what is the difference when you use like the wiggly and then the Q, or the wiggly and then the P, because they also show like the P there, up there, you know, on the
So you
solution.
can put not Q, that's gonna be not Q. And if that's not P, then it's gonna be not P. So it's just negation. You can negate just about anything. For example, you can negate Alex and you're gonna get not Alex. So you can put this negation in front of just about anything. And that's, I guess, good to realize. So you negate anything they want. For example, in their checkpoint 3 that says that Chicago O'Hare is the world's busiest airport. To negate that statement, what they want is they say is not. So that Chicago airport, you just put is not world's busiest airport, and that'd be negation. Whether it's a correct statement or not correct doesn't really matter to us right now. All we do is just we negate things. And that's another part of this class that sometimes people don't feel comfortable about, because sometimes there's some statement that we find in the textbook that you may not agree with, but that's okay. You don't have to agree with it or disagree. You just want to follow what they say, because some people that experts in airport may say, yes, this is the busiest, but some others say, no, no, I know this in Hong Kong or who knows where is it even busier. And that's why this is not the busiest airport. So yeah, but we don't really care in these sections whether statement is going to be making sense or true or false. We're just making a statement and they say negate it. Well, then just put this not in front and that's it. So that's all one needs to realize. So negation, that's a, I would say, notation. That's a special shortcut way to write down things that we otherwise would put in words. So instead of word not, we just put this wiggle. There is a little table here that worth considering. And in this little table, they're talking about some of the negations and how they change our sentences. So this is probably interesting to consider. So here's the all ARB. So what does that mean? Well, if you try to think of Venn diagram, and if you produce picture with A inside of B, then you're probably gonna get a better understanding what is going on in here. So no matter what elements you find inside of A, you're automatically gonna stay inside of B as well, right? So because all elements of A are in B. So that will be, I guess, intuitive picture of that statement. And they're actually trying to show this with a real life example that says all poets are writers. And here's the analogous Venn diagram for this. It says that poets and writers correspondence, and looks like if they say all poets are writers, I think it goes the other way around, right? Because I think what's supposed to be here, let me get some room on the side. I don't think that's the actually picture of what I just tried to present. I think it's a picture of later part. I think it's going to be one of the later things. So that's why we should not worry about it at this moment. So what I want to do is produce analogous Venn diagram for the underlined statement. So that says the writers, just put WR, and the poets will be inside. So poets will be inside. So probably that's something that could be making sense out of. So if you are poet, then you automatically write something, then you're also a writer at the same time. So the poet found is also found among writers. So looks like this analogous Venn diagram to the one that I just had on the left side is also present in here. So how about a second portion of this little table, the second row? I just want to get some room here. Well, it says that some A are B. So what's the difference here with the previous statement? Well, the difference is that there are some elements of A that belong to B. So if I try to think of it in terms of Venn diagram, and if I put B here, just like did before, now A does not have to be entirely inside of B, because some elements from A are also in B, but some elements may not be inside of B. So the difference is that sets A and B could be just intersecting, and A does not have to be entirely inside of B. And that's interesting to think about, right? So next situation could also be shown by next Venn diagram. So maybe I'll put it a little bit to the left because I need to fit it here. So maybe I'll just put it right here. So another Venn diagram that says no A are B. So what does that mean? Well, if my set B is here, but there are no elements of A that belong to B, it means that these two sets, they don't intersect, right? So it looks like that statement talks about the mutually exclusive. Sometimes people say, remember, if I try to find their intersection, then there'll be no A will be element of B. So I can utilize empty set to write down this statement once again. So please notice that I produced three different ways to describe that statement. So first is what they wrote with words. So no A or B. So it means that whatever you find in A, it's not in a B. So that's a second way, Venn diagram. I guess that's probably the most intuitive. And a third way to write down exact same thing is shown here with the empty set. Why I show it the third way? Well, because in the later pages of this textbook, you will see something like that. So that's why I guess it's a good idea to show it. Well, words to think about, right? And finally, there is a fourth situation in here that talks about some A are not B. And I believe that this is also described by the picture in here. So some A are not B, as just shown with the pink dot. So there are some elements in A that don't belong to B. Some may be, but some are not. So it looks like the situation with two sets of intersection is already utilized here as well. So if you start to think how else you can possibly put those sets together, and you probably won't be able to find any way. So either one belongs to the other entirely, or there is no overlap whatsoever. People call it as mutual exclusive sets. And the most popular one would just have an intersection, and that's for the case number 2 and case number 4. So it looks like that's what we will be dealing with in here. And this first section is just introduction to this story. So it'd be a good idea to maybe think over what I'm doing today once again. And let me try to put down an exercise for you. So maybe I can clear this a little bit. So let me clear this real quick like that. Share this again. So these exercises will be utilizing words, and again, take a look at the negation part here. So form negation of each statement. So if somebody says it's raining, what you're gonna say for exercise number 15, it's gonna be it is not raining, right? So that's how we put a negation. So you just put not, and that's all you need to do. So it is not raining. So probably analogous you will utilize for the others, which is kind of interesting. So how about if you try exercise in the next group, like number 21, that says, one does not work hard. So in exercise 21, looks like they talking about statement that deals with P above, but it also has negation in it. So what I can say, it's going to be not P. Do you see that? So if P says one works hard, then if I want to say no, one does not work hard, well, it's going to be a negation that we put in front. So it looks like this little story is all about negations, and I hope you start to feel a little bit more comfortable with this. So maybe you can try exercise number 24 for today's little quiz. So it'd be pretty much same answer as I just put in there. But I know that this wiggle you may have hard time to find on some of the keyboards. Maybe on a computer you can find, but not on the cell phone if somebody uses cell phone. So what you can do for the answer, you can just put like not P. So that'd be exactly the same thing as to put that negation. So just let me know which one of these 4 are being used here in the exercise number 24. And I guess that'd be our quiz for today. So it talks about heater being working. Is that statement, or that's the opposite of that statement? So is that, let's say, Q, or that's not Q? So please don't hurry, just think about negating one of these 4 statements, or just keeping them the way they are. So again, that's our today's quiz. I'm going to stop recording.